So far in this video series that has been showcasing my path from going from the average web developer to more of a good engineer writing efficient code, better code and stuff instead of just building the thing and making it work. I've gone through mostly discussions of talking about high level concepts with programming that I'm learning that I didn't need to know before, to hopefully give you kind of an entry point at the high level to make it a little less scary to go through and learn those topics yourself, and give you a little bit of motivation that, if I can learn it, then you can definitely learn it as well. So today's going to be a little bit different. Instead of talking about an actual programming practice, we are going to be discussing, how you should program, I guess. More specifically, I want to go into um, this concept of running a profiler. So, if you don't know what a profiler is, I kind of had a small assumption, but I had never run one. I had never felt the need to run one. I've written some really bad code that would very much benefit from this. But hopefully, we're going to talk about these programs, what they do, and why I've gotten to the point where I don't develop without running one now. Whenever I'm running tests, I'm running a profiler, assuming I've written actual new code that I want to kind of look at. So, what is it? What is a profiler? In essence, this is a program that tracks kind of sometimes memory, depending on how you set up, but most typically the runtime of certain pieces of code within your program, and spits them out in some sort of easy to display thing. So, perfect example is. And this is a little preview for what we'll see later, but if you've ever opened the DevTools and gone over here to network, right, and I refresh this, so it'll load a bunch of things. It'll show kind of what all the pages load time, you can kind of like track through how long everything's taking to load, the time that it loads. This is a profiler of the web page loading. And you can pretty easily apply this to your code yourself. A lot of languages, a lot of runtimes have a built-in profiler. So what I'm working with, Odin, kind of has one. You just saw a setup for, or the web page for it. It's called Spall. It's included in the core library, in a profiling package in the core library. So it's not like, in theory, just run a command and it runs it for you, but it's pretty easy to implement, and I can show you a very basic implementation if you're writing Odin as well. Spall is also available in C, C++, from my understanding pretty easy to install and set up as well, but I haven't written those languages, so I can't know for sure. But I do know Node.js has a built-in runtime. Go has a built-in profiler to run during runtime. I believe both of these are just some sort of command, a flag on the command line. I haven't written them yet since I've started kind of doing this practice, but I believe that they're pretty built-in, easy to use. I'm sure a lot of languages do have these built-in profilers, or very easy to install ones, so that you can see this is kind of a widely accepted practice to at least have these available, so you can debug things that are running pretty slow a lot easier. So why should you develop with these? Why should you use them outside of, like I talked about, something's running in 20 seconds and you feel like it should run in 500 milliseconds or something, so you actually need to see what's taking so long so that you can sit down and fix it. And the idea is learning, right, or education. When you sit down and you see like that functions are running for microseconds or milliseconds, like seeing that, like, oh, this is running in 10 milliseconds over 10 milliseconds over 5 milliseconds, like if you even can figure out how to bridge that gap, right? You think it should run in 5, or it was running in 5, you implement like one addition and it goes to 10. Fixing that back down to 5, it doesn't matter for your program, right? So that's like why it would be easy to just kind of ignore these and keep moving. But the idea feeds back into learning, right? We don't necessarily care about that 5 milliseconds, but we care about learning how to efficiently program so you can quickly fix these in the future and even identify them as you're writing code. So in essence, if you're working something really fast, you don't need to, you need to get it up and running as soon as possible. It doesn't matter quite as much because, like I said, earning that 5 milliseconds isn't going to be super impactful. But when you're sitting down and writing a project that you have time to write, being able to see these and understand, why this exists, like what the difference is if you can fix this, then when you're writing in the future, you won't make these mistakes, or what could be considered mistakes. Or if you're in a super performance critical part of the application that you're writing, you can instinctively just write better code as you're learning. So I think that like these are super important to run while you're learning, so that you can see kind of, even if it's like these really, really tiny gains, you can understand, if I'm switching how we do math on a 10 element array, if I then upsize that to 10,000 elements for whatever reason, down the line, it doesn't even have to be in that piece, but doing math on an array later, then you'll already have this image in your head of how to implement this correctly, right? You won't have to sit there and learn and make the mistake, and you will be able to implement it faster. This shows up a lot in Python with array math. So, if you want to add all of these together or add them to another array, we know we use NumPy, kind of, I think, with Python. Sorry, I'm not showing that, but I'm not super, deep into Python. But, you can use kind of these two solutions to do array math. And there are some instances where one's better, some instances the other's better. Actually, Casey Muratori goes into it in Computer Enhanced, but I don't remember off the top of my head which one is better in which circumstance. But if you make this more efficient, you go from a normal addition to NumPy, you go from a normal addition to sum, and you see that this goes, again, this is Python, so we are probably working in milliseconds. This goes from 10 milliseconds to like 1 millisecond. Again, that's not a small gain, but then you take this and you make it, 50,000 elements. You would, in theory, expect kind of a linear, scaling of this time. So it goes from, 10 milliseconds to 500,000 milliseconds. Or 500 seconds. And now you're entirely cutting a zero off that. So instead of that, it's running in, 50,000 milliseconds or 50 seconds instead. So it's running in 1 minute instead of almost 10. These are things that are good to be stuck in your head, to kind of see these and be able to write, programs a little more efficient. I know I'm pulling a little bit of numbers out of my butt here, but again, the idea of this series is to see from a beginner point of view, to understand, I'm going to make mistakes, hopefully, because I want to show you can make mistakes. But I believe that, this is a good thing to do in the long run in your learning process. Like I said, running it in terms of building production applications, especially when you have a tight deadline, not necessarily the case. You don't necessarily need to do that, but I think, coding with one kind of side by side is important, as you can kind of like look through these things as you build them and see, what's faster than others. And then you'll also be able to kind of design your applications better. If working with an object is, much slower in this instance, even, I know there's some instances where searching an array is faster than looking up in a hash table, if the array is like 2 to 5 elements, depending on the language, depending on the circumstances where the array is, that kind of stuff. But like those are things that you'll be able to pick up on, looking through this. So running to a demo of how I've done this in the game, like I said, it's kind of built into Odin. So you'll see up here we are able to import from a profiling package, a package called Spall. I'm not going to pretend I fully understand what's going on here. I just understand to kind of a basic extent that we are creating a context to a file. We're creating a buffer that will allow the profiling to write to it, and then we are passing events to this spall package along with the buffer that it will write to. So you see here, this is starting a scoped event that is main, and then down here we do another buffer begin kind of event to mark where each frame begins running and how long the frames take to run. And then as the last piece all the way down here, this is a little bit more complex Odin, even than I really fully understand what's going on. But the idea here is every time we enter a procedure and we exit a procedure, we start and end a buffer. This is not perfectly exactly what it is tied to procedures, but because you can mark procedures as no instrumentation and other things, but that's the general idea. So you'll see if I go up here and we can run Odin in debug mode. So this happens because we have we're setting this environment variable to Odin debug. We are running the spall stuff. So if I do like a release version, when statements in Odin, if they are false, they have to be able to be calculated at compile time. So if they're false, then the code is not at all included in the release executable. So here we'll go ahead and run it. We'll load up a super basic game. Takes a little bit longer to load because we are, initting more things when we're in debug mode. But we'll just run around. We'll hit we'll do some little jumps, and then we'll close it. And what this will do is this will spit out, like I said back here, we initialize this profile.spall file. Spall, you can look at the web. We saw a little bit of this, but go ahead and start Spall. This will show you the profile for loading this page, I believe, or loading the, maybe it's loading the Spall application. But so we spit out this Spall file. This is what we're going to look at. We can upload this super quick. It spawns. And initially you see the scoped event. This is the main event. This is, I can... high level, something's a little bit weird with the overwriting of the instrumentation that I pointed out, and so sometimes the scoped event gets overwritten, but this is the main, and then you'll see if we zoom in, you have all of these frames. These frames are running every 16.7 milliseconds. This is specifically supposed to happen because we're running at 60 FPS. That's the idea, and then you'll see these little bars, tiny bars. So to see even those, you'll have to zoom in way more. And so this is basically, the game logic that's going on. So every frame we start a render, we step the world, which this has to do with the Box2D physics engine. This is the function that kind of moves the world forward one frame. And then we draw the player. So it's very simple right now, like I said. And then I think, at the end of the frame, we also check if you have moved. And this is because rendering kind of takes a lot of the frame, like if you give it an entire frame, it will take pretty much the whole thing besides the logic that needs to happen at the end. And then if you really want to get down into it, so like I said, this is super basic, but later on, I believe, so kind of at the beginning, you'll see a lot more init events. I think this is where it's going to be, more interesting. We're doing these logs, we're checking the FPS, we're doing these logs. So if we go back, you'll see that I have a log set up when we drop our FPS below 60, which is going to happen a lot when you're initting. Kind of makes sense as you're setting up the whole world and drawing everything. But this is like super deep into, every piece that's running. This isn't, necessarily super, super useful to us, but you still do see if you've written your own, logger using a specific logger package, you'll be able to check, when I log something or multiple things, depending with the Odin built in, it takes, 166 microseconds. So if I install a new package and it's taking 50 milliseconds, maybe we should reevaluate kind of what's going on there. So like I said, you just get a ton of information from profiling the things as you're working. And then it's super important, like with games, like you want to be able to run everything in the frame, right? You don't want to be losing frame rate because you're running over a lot of business logic. So like that's super important to like see it relative to the frame. But I think this is important for every, processing time, load time application you're going to run. So hopefully, maybe I've convinced you, maybe I haven't, but at least you've been able to build some arguments against this. I think it's a good idea, but you can kind of, fit profiling into your development process wherever you think it will be the most helpful. So if you made it this far, go ahead and leave a like and comment. Make sure you hit that subscribe button if you want to see more of these episodes and, keep walking with me in the future, becoming a better developer.